Sorry students, due to our network problems, there is our link is opened, not open. It is okay for you all now? It is okay for you? Tell me all the students, it's okay for you? Yeah, thank you. And now there is what we are going with our next concept, that is only what here? Yes, reflection of light at a curved surface, at a plane surfaces, refraction of light at a plane surfaces. Yeah, in the last class we are discussed till up to our whatever the relation is there between incident angle and as well as the refracted angle. Okay, that is only now today we are continued based on that particular topic only, that is the Snell law. Okay, very important law. Yes, and that is fundamental law for the what refraction. Okay, the refraction mathematically is taken from the where, taken from this particular, okay na, yes, this particular law only, mathematically whatever analyzing is it is there, that will be totally taken from this particular law only. Okay na, that is only we have to go to discuss now. There is already we are once we check here, and last class what we are discussed, that experiment everyone is have idea or not, the simple experiment only. From that one there will get the relation between the what is the incident angle, what is the refracted angle. Clear or not all the students? Now come to the page number 54, activity 4. Okay, clear or not all the students? You have to take, there is activity 4 here. What is activity 4? Once you have to go to check here what is activity 4 there. Yes, take a metal disc. Take a metal disc, use a protractor and mark the angles along its edge as shown in figure. Yes, arrange 2 straws at the center of the disc. Yes, in such a way that they can be rotated freely, yes, about the center of the disc. Adjust the straw to make an angle 10 degrees. Immerse half of the disc vertically into the water. Fill in the transparent vessel and while dipping, verify the straw at 10 degrees is inside the water. From the top of the vessel, try to view the straw, yes, which is inside the water as shown in figure. Yes. Then adjust the straw which outside the water until both straws appear to be the same in a single straight line. Yes. Take the disc out of the water and observe the 2 straws in it. We'll find they are not in a single straight line. Why it is occur actually? Okay, once check it out here. Without the light also may possible to do this experiment. Okay, clear or not? Simply you have to take some amount of water, yes, in the bowl. Okay, which is taken as a transparent nature of a bowl we have to take here. Okay, clear or not all the students? Simply you take a protractor here. Okay, clear or not all the students? You take a protractor here and you take one straw also here. Okay, clear or not all of you? Yes. Just a minute. We are taking here. There is already we have. Yeah, once check here the student, this is only the experiment purpose we have to take here. Clear or not all the students? There is a what once you have to take here. I hope you understood this total thing. Yes, there is a what, it is a one type of a protractor only. You take a metal disc like this. Okay, clear or not all the students? And this metal disc here contains a what actually? Yes, there is a what, it is may appear or not all the students? All the values. Okay, it is a 0 degree, 10 degree, like that it will be there or not? It is appear for you, I hope. Yeah, may it is appear for you or not? I hope it is appear for you only. There is a one check it here. There is a, this is the 90 degrees. There is also it is somewhat a 90 degrees we are taken here. Clear or not all the students? It is a 90, it is a 90. Once take it here. Yes, you dip our whatever our you take like this it is. There is a what? You take this our whatever it is a what on a plastic, it is a bended thing. You are take it is a water. Why? Because it is a when it is a bended, automatically yes will get the correct values. Yeah, I'm taken it is like this it is. Okay, it is now in a straight line form only. Now it is in a form of a straight line only. Clear? When you take it is at a 10 degrees. Now it will be looks in the form of what here also at 10 degrees only. Once take it here, it is a 10 degrees. And when you put it is at 10 degrees, it is also at 10 degrees only. But it is a what now appear like this only, it is a 10 degrees. Why? Because suppose I am taken for our convenience, there it is a 30 degrees. It is a 30 degrees. Now it is at a 30 degrees. It is also 30 degrees only. Okay, now when you make like this, there is a what? It is at it is where it is? It is at 90 degrees. Now there it is a 90 degrees. Now you dip. There is up to here. You dip it is into the water, and then after you are take a somewhat angle here. But it is not look in a form of a straight line when it is a dip in the water. Okay, clear or not all of you? Somewhat it will be looks into opposite manner. Actually it will be not available with me. Whatever our transparent okay now, yes, this much of transparent big ball are not available with me. Okay, clear or not all the students? Yes, you do this experiment if possible. Yeah, what is going on? There is may it look somewhat in a bending format. Clear or not all of you? It is a look somewhat in a bending format. How? Okay, like this it is. Yeah, now it is in a straight line only. But when you take it is in the water, once take it here, it is in the somewhat a bending or not? Yeah, it is a bending in the form. Okay, clear or not all the students? Now suppose it is a 10 degree, but it is not appear as a 10 degree. So you want to make it is about actually you want to bend like this it is. For the getting into the form of a straight line, you want to bend it is like this it is. Okay, it is now not in a straight line form. Okay, once check it here like this. Okay, it is not in the form of a straight line. You want to take it as a straight line manner. You want to bend somewhat it is in this manner. Okay, clear or not all the students? Now it is a look somewhat in a straight mode only. But it is how it is possible? Because of the bending only. Because of the bending only. Okay, now in this way you change that angle 10 degree, 20 degree, the corresponding refracted ray will be get for us, refracted angle will be get for us every time you made it like this only. Okay, clear or not all the students? Now, yes, Suppose I am taken it is here at 90 degrees. You have what is our experiment? Once again I am taken this once I want to explain about this experiment. Okay, now just you take a metal disc like this, and by using the protractor, you at the edge of that metal there is a what you have to take angles, all the angles. Okay, clear or not all of you? Yes, like this angles you have to take here, and now there is where is the 90 degrees at that particular place. Yes, up to that you have to dip that our metal disc into the water automatically. Yes, then now you rotate this particular straw, whatever the straw is there, you rotate somewhat any other angle. First you take from 10 degrees. This is the 10 degrees. Actually this is the what actually this is the 10 degrees it will be there, or otherwise you take it is the 10 degrees. Now at where it is now, both are at 10 degrees only. Then after when you take the water up to here, up to this particular 90 to 90, you know very well at normal 90 to 90, okay, now there is automatically 90 to 90, there is a what? It is automatically, yes, that is only surface of water. When it is a dip inside of water, automatically it is not look like a straight line, and you have to hold it here, and then you bend like this, it will be what? Changes its angle. Okay, for this instance, there is a not possible to change whatever inside of this. Okay, now there is a bending like this. Okay, now automatically there is a angle may decreases or increases. Which angle? This one, whatever the air it will be there. Okay, it is in air now. Above the part of 90 and 90 it is air. Below the part of 90 and 90 it is in a water. Automatically that whatever the above part of this straw is there, somewhat bending, means what? The angle is increases. Yes, it is at 10 only. It is at 10 only, but this part is increases. Okay, clear or not all of you? Like this, when you bending it is, you hold like this, and it is a bend like this. It is a what actually looks like in the form of a refraction. Okay, clear or not all the students? Yes, this corresponding angle, there is a refracted angle is become 10 here. This angle may not 10 hit here. It is made 10, which is a 10. Below the water it will be 10. But above the water may not hit at 10. From this one you calculate that all the values of corresponding incident and refracted angle. Okay, clear or not all of you? Corresponding incident angle and refracted angle. You take like that up to 5 values. Once check that. Yes, once check that all the 5 values. Yes. Suppose I is a get for us in this manner. You have to take in this manner. Okay, now clear or not? Yes, there is a what? There is a 90 degrees and 90 degrees. Suppose we are at a 10 degrees. It is also 90 only. We are at 10 degrees. The star. Yes, initially there is a both are. There is a what? It is a water we have taken here. Yes, it is a 10 degrees. It is a 10 degrees, suppose you are taking it is a 10 degrees, but it is not at a 10 degrees, looks as a straight line. Somewhat it is a looks like this bending. Okay, clear or not all of you? Somewhat it is looks like in a bending manner, and you made it is a bend that not from 10 degrees to another any other angle. At that time only it looks like a straight line. Okay, clear or not all of you? Yes. At that particular point, what is the correspondent angle is there for this refraction? Okay, now what is the correspondent incident angle is there for this refraction? That once you noted it, according to our refraction laws, you know very well, when the light is entered from the rarer media to the denser media, then automatically it is the bending towards the light ray, the bending towards the normal. In case it is somewhat 10 degrees, compulsory it is below the 10 degrees only. Okay, clear or not all of you? Yes? Got it or not all the students? It is a 10 degrees, it is may not compulsory not 10 degrees. It should be less than the 10 degrees only. Okay, clear or not all of you? Which one, this denser media, whatever the light ray is there, it should be less than the 10 degrees only. Okay, that once you get it here. Yes, then after, whatever the angles are there, suppose it is at 10 degrees, it is at 10 degrees, it may not be at 10 degrees. It should be compulsory contained at the what? It should be contained at somewhat at 20 degrees as a straight line. Yes, actually in a normally the manner, when it is under refraction, it will be shown like that. Okay, but we want to require one straight line here. Yes, we want to change the location of our incident path. Okay, what is the difference is there between actual appearance to this particular straight line? That is only become the difference between the angle of refraction and angle of incidence. Got it or not? Yes, and that is you have to take here. Suppose I is equal to 20 and R is equal to 10 will get for us. In case, imagine that I is equal to may get for us 20 and as well as R is equal to may get 10. Okay, you have to take the ratios of these angles with the what sine angle, sine I and as well as the sine R. You take the ratios of these two things, it's compulsory. It must and should be equal to what actually? It should be equal to refractive indices. It should be equal to the refractive indices of that media. Okay, that is only called what actually? Snell law. Snell law, it means that the ratios of angle of sine, angle of the incidence of a sine, angle of incidence of a angle of refraction of a sine is equal to refractive index of our that media. Okay, that is only called actually Snell law. Yes, here there is a what, in case there is a what we have taken. Yes, suppose N1 is a refractive index of which one it is? N1 is a refractive index of incident media. It is a taken as what? Compulsory you have to take this is a what? Incidence media. N1 is a refractive index of incidence medium and as well as N2 is a refractive index of refraction medium. Okay, clear or not all the students? At that time only you have to possible to write it is as a sin I by sin R is equal to N1 by N2. Clear or not all of you? That is a very important. It is about relative refractive index or not? It is also called a relative refractive index. Here, it is taken as taken as what? N2 by N1. Okay, clear or not all of you students? And now there is you know very well. N2 by N1 is equal to what actually? N2 by N1 is equal to taken as V2 by V1. V2 by V1. From this one, what you written? Okay, now from this is the taken as equation number 1, this is the taken as equation number 2. From these two equations, it is also written as sin I by sin R is equal to taken as V. Yes, that is written as what? V1 by V2. V1 by V2. Clear or not all the students? Yes, in this way there is a what? It is given the relation between the speeds also. The Snell law is also given the relation between the speeds of light ray also. Once again I want to explain students, one check here. There is a what, you know very well, compulsory what we required for the refraction, two medias are required. One is the rarer media, another one is the denser media. Okay, suppose you have to take the refraction indices of the incidence, whatever may be, that is rarer media or maybe the in denser media. You have to take any of one media as an incidence purpose. Suppose I am taking this is the what actually, this is the rarer media I am taking here. And now there is a what, the light is enter from the source and it is a fall on the rarer media. It is a become what, incidence angle. Automatically it is a, when you take it is a denser media. It is a denser media. Now our light ray is bending towards the normal. What is this one? It is R. Okay, suppose you take a refractive index of this media is taken as N1 and the refractive index of this media is taken as N2. Okay, the refractive index of this media is taken as N2. The relation is written as between the what? Sin I to the sin R. Sin I to the sin R like this. I hope you understood. There is a what? Sin I by sin R is equal to what? This N2 by N1. Clear or not, all the students? And now there it is also written as what we have taken here. There is it is also written as the N2 by N1. The N2 by N1 is also called what? Relative refractive index of the medium. Relative refractive index of the medium. Already we solved what is the expression for the relative refractive index of the medium. Yes, already you know very well about this. Once again I am not required here. Okay, clear or not, all the students? Yes, relative refractive indexes. And how do you get this N2 by N1 is equal to V1 by V2? Already we completed about this now. You know very well what is the refractive index? What is the refractive index, students? Yeah, the refractive index is written as the velocity of light to the velocity of the medium. N2 is equal to C by V2. And automatically N1 is also become what? C by V1. N2 by N1 is become what actually now? There is. It is also written as C by V2 by C by V1. C by V2 by C by V1. Now C and C cancel get each other. N2 by N1 is equal to also written as 1 by V2 by 1 by V1. Got it or not, all the students? Now it is equal to also written as N2 by N1 is equal to V2 by V1 by V2. This is only the relation. I hope you got it. I hope you got it. It is N2 by N1 is equal to V1 by V2. Okay. Yes. In this way only you have to calculate that relation. Okay. No? Yes. There is a what we have get for us. There is a N2 by N1. It is indicates what actually. That is N2 by N1 is also written as N2 by N1 is also written as N21, relative refractive index of the two medias when it is like this. Okay, clear or not, all the students? When the light ray enters from the rarer media to the denser media, the relative refractive index is taken as N2 is 1. The N21 is equal to what? N2 by N1. Okay, now there is a whatever a sin I by sin R is equal to what actually? Sin I by sin R is equal to relative refractive index of the two mediums. Okay, clear or not, all the students? In case the light ray enters from here to here, at that time, may it is written as N1 by N2. This is become incidence angle now. This is become incidence angle. This is become refracted angle. Very, very important. The somewhat confusions are there here. Yes, about the ratios are written. When you written the ratios, don't confuse. Simply, there is a what? Sin I by sin R is equal to reciprocals ratios of refractive indices. Otherwise, it is also written as that whatever the sin I by sin R is equal to relative refractive index of the two medias. The relative refractive index, how you written already we are discussing. Okay, clear or not, all the students? Relative refractive index, how you written, you know very well. Already this is only the about the refractive indices, how it is converted into the this formula. And now there is a what we have N2 by N1 is equal to V1 by V2, and combine these two equations. Why? Because sin I by sin R is equal to N2 by N1 is nothing but this RHS is equal to this LHS. That's why it is also written as sin A base NR is equal to V1 by V2 also. Okay, it is indicates what actually? It is indicates what actually? Yeah, it is indicates the relation between the incident ray to the reflected ray and the velocities of that rays also. Based on the incidence angle and velocity incidence angle and as well as the refracted angle, you will get the velocities of the light in the medium also. Okay, clear or not all the students? Based on these values, we are estimated the what is the value of light in the first media. This R, sin R is indicate the what is the value of velocity in the second medium. This is also good for us. Okay, clear or not all of you in case you don't know about the velocities. Okay, that experiment will be useful for finding the relative refractive indices. And also it is a gives for what? Velocities also. If possible tomorrow, I want to go with the what actually, what is the relative refractive indexes of glass or water. Okay, clear or not all the students? Yes, and this is only about our total refractive indices and Snell law. Yes, the Snell law statement is a very important. And these relations, don't confuse, compulsory you have to know what is the relative refractive index, and from that one only you will get this thing. Okay, clear? I hope you understood. Once you today you complete that activity 4, once you read that activity 4 and note down in your classwork these are the formulas. If you have any doubt from this formula, you have to take this all the formulas also. From this particular formula, once you derive it, you will get it, all these things. Okay, now before going to this chapter, you have to compulsory read that relative refractive index. Then after automatically, based on this our activity, you will get that all the remaining things. Thank you, bye, take care.